Hello everyone, myself Dyvin Biju. I am currently pursuing MCA at Marian College Kuttikkanam Autonomous. In this video, I will explain how a simple idea from graph theory called graph coloring helps computers run programs faster and more efficiently. When a program runs, the computer has to manage many variables at the same time. However, it has only a small number of very fast memory locations called CPU registers. So a natural question arises. How does the computer decide which variables can safely share these registers and which cannot? To solve this problem, computer science borrows a powerful idea from mathematics known as graph coloring. Although it comes from graph theory, graph coloring plays a crucial role in real-world systems like compilers. Let us first understand the basic idea of graph coloring. A graph consists of vertices which represent objects or tasks, edges which represent conflicts or relationships. Graph coloring means assigning colors to vertices such that no two adjacent vertices share the same color. Here, colors do not mean red or blue. Instead, they represent resources such as time slots, memory locations, or CPU registers. The main goal is to use the minimum number of colors without causing conflicts. Now let us understand the importance of graph coloring in computer science. Many problems in computer science involves limited resources and conflicts. Examples include task scheduling, frequency assignment, and memory management. One of the most important applications among these is register allocation in compiler design, where efficiency directly affects program performance. Now we can see one of the application of graph coloring, that is during register allocation. CPU registers are extremely fast, but their number is very limited. During program execution, many variables may be active at the same time. If two variables are used simultaneously, they cannot share the same register. This situation is very similar to graph coloring problem, where conflicts must be avoided. Here is how graph coloring is applied step by step. Each program variable is treated as a vertex. If two variables are active at the same time, an edge is drawn between them. This forms what is called an interference graph. Here, graph coloring is applied, where each colors represent one CPU register. Variables with the same color can safely share a register, while connected variables must use different registers. The objective is to use the minimum number of registers efficiently. Now let's consider a case study, GCC integration. A real-world example of graph coloring technique can be seen in GCC compiler, which is widely used in Linux systems. GCC constructs an interference graph for program variables and applies graph coloring to allocate registers. If registers are insufficient, then less important variables are temporarily moved to a memory, a process known as filling. This approach helps GCC generate optimized mission code. We can connect the concept of graph coloring with an exam scheduling in a college. Subjects with common students cannot be scheduled on same day, just like adjacent vertices. Different exam days act as different colors. The aim is to conduct all exams using minimum number of days, similar to using the minimum number of registers. Conclusion. Graph coloring is not just a theoretical concept. It is a practical and powerful technique used in compiler design to manage limited resources efficiently. By applying graph coloring, compilers can generate faster and more optimized programs. Thank you.